Hello students, welcome to today's video. As promised earlier that I would make a complete video on the marginal rate of substitution. So this video is basically relates to the full explanation of the marginal rate of substitution. So without any delay, let's get into the full details. So the marginal rate of substitution. And this marginal rate of substitution is popularly in shortcut said as MRS. Okay, so now what it is? What do we mean by the marginal rate of substitution? Well, during the video of indifference curve, I have told you that marginal rate of substitution is the amount sacrificed in one commodity in order to consume one more extra unit of another commodity. So we can write the same definition. It is the amount sacrificed in one good, say suppose good Y, in one good in order to consume one more extra unit of another good, say good Y, good X. Now there is also a mathematical relationship also. Now before going into details, let me tell you that good Y, that could be any commodity and good X could be any other commodity. Say suppose good Y can be said as it is what to say, it is pen. Good Y is pen, and it is suppose pencil, any commodity. This could be a shirt, this could be pen, this could be bread, this could be butter. So in general I am just referring by two variables X and Y. So MRS is basically known as the amount sacrificed in one good in order to consume one more extra unit of another good. So in order to calculate it mathematically, that it can be calculated as, it can be calculated as the ratio of change in good Y. I'm just writing in short GY. GY means good Y, but you guys go with the full good Y. Amount change in good Y to the amount change in good X. So symbolically it can be written as MRS XY. Now why MRS XY? Because I want to increase consumption of one commodity, and here I have written that I want to consume one more extra unit of good X, and for that reason I am sacrificing some amount of good Y. So hence I have written it is the amount sacrificed in good Y in order to consume one more extra unit of another good, say good X. So that means I want to increase the consumption of good X, and for which I I am sacrificing the consumption of good Y. So this is the logic why we write MRS XY. The first variable X, that one represents the commodity for which we want to increase the consumption, and the later one, last variable, represents Y, that represents another good for which we want to reduce the consumption. So it can be written in another way, MRS YX. So here we want to increase the consumption of Y and reduce the consumption of X. So anyways, let me first give this. Now how it can be calculated? That it could be calculated as the ratio of change in amount sacrificed commodity, that is the good Y, ratio of change in Y to the change in X. So this is the mathematical way how we can calculate MRS and MRS XY, and this will be here. I want to increase the consumption of increase the consumption of Y, for which I will sacrifice the consumption of X. So it is the ratio of change in amount sacrificed commodity, which is the good X, and to the amount of increase in consumption of commodity, that is good Y. So this is the main idea behind the marginal rate of substitution. And let me tell you that this marginal rate of substitution is always diminishes. Now there is one reason. Well, you can take a screenshot also of this thing. Anyways, the marginal rate of substitution is always diminishes. The reason is that behind this MRS, one more law it is also is happening. That is the diminishing marginal utility law. The law of diminishing marginal utility. Sorry, I got a bit confused in between. I got jumbled up with my words. So pardon me with that. So anyways, so behind the scene, behind this marginal rate of substitution, the law of diminishing marginal utility is in operation. And due to this law, the MRS is always diminishes. Now, what does the law of diminishing marginal utility says? That it says that if we try to consume more of one good, the marginal utility gained from each successive units of that commodity diminishes. So here we have defined our MRS XY, where we want to increase one more extra unit of good X. We want to consume one more extra unit of good X, and for which we want to sacrifice some units of good Y. So it is the amount sacrificed in good Y to the amount sacrificed in good X. Change in Y due to change in X. So anyways, coming to the point. So MRS is always diminishes. So now here we want to increase the consumption of X commodity. So if we increase the consumption of X commodity, what will happen? The mu gained from each successive units of X will tend to diminish, and as a result, what will happen? You will try to sacrifice, because and let me tell you, this MRS is basically the slope of indifference curve. MRS is the slope of indifference curve, and it always diminishes due to the operation of LDMU due to the operation of law of diminishing marginal utility. Now coming to the point that we have defined MRS is that MRS XY is that change in Y to the divided by change in X. Now we are saying that the MRS is always diminishes. MRS is always falling. Now why it is falling? Because here he wants to increase the consumption of X. As he goes up increasing the consumption of X, each unit he consumes, the additional benefit, that is the marginal utility that is derived from additional consumption units of good X, tends to diminish. So if that tends to diminish, now here we are also saying that MRS is the slope of indifference curve. So by the very own definition, indifference curve says that if in any point of the indifference curve the consumer gets same level of satisfaction. Now here the as the units consumed of good X is increasing, the marginal utility of good X is decreasing. So as a result, what will happen to be his in indifferent position, he will sacrifice less and less amount of good Y, and due to all these reasons, now the MRS will not be an increasing thing or will not be a constant, rather it will be diminishing. Now this can be explained with the help of a table. So with this table I am also showing how to make this table, what is the trick to draw. So the table is the same as like what we have did in the indifference curve. Here combination, A, B, C, D, E. Say suppose here we take one good X and here good Y, and here we are taking MRS XY. Good X 1, 2, 3, 4, 5. Now please do not fill up this good Y column. We know that the MRS diminishes, so let us diminish it like 5, 4, 3, 2. Now from the indifference curve definition is that we know that he always consumes two commodities. So in any of the combination, all the combinations will be non-zero combination. If anyone here becomes 0, so suppose this one, first one becomes 0, that means he is consuming only good X and he is not consuming any units of good Y. So this will violate our very own definition of indifference curve. But this does not restrict that it will not be good. We cannot have 0 here. In some extreme cases also we can have 0 here, like say suppose if good X is rice and good Y is Y2. So which one is more important? Obviously good X is more important, so we will have more rice and we will not ever have any of world 2, because we need to first survive, then go to the world 2. But anyways, here we are sticking with a very simple thing, that indifference curve, a consumer always consumes two commodities, and hence for here all the combinations will be non-zero. Now how to fill up this table? First you fill up the combination column A, B, C, D, E. Note down some amount of good X and note that the amount increase in good X is always increasing one by one. 1, 2, 3, 4, 5. If we rewind this video, you will find that we have defined this MRS is the amount sacrificed in one good due in order to increase consumption of one more extra unit of another good. Hence here we are increasing the commodity of good X, the X commodity, its consumption we are increasing by one more extra unit, 1, 2, 3, 4, 5 and like that. Now how to fill up this Y? We have also know that MRS diminishes, so we have made a diminishing list 5, 4, 3, 2, 1. 3, 2. Now let's fill up it. Let's start with any number. As we have stated, this cannot be non-zero. Now say suppose 3. Now let's just add it. 3 plus 2, 5. 5 plus 3 is 9. 5 plus 3 is 8. 8 plus 4 is 12. 12 plus 5 is 16. So now if we also go to this side also, you will find the same result. For the first commodity there was no change, he was consuming this bundle. Now as he went up on increasing commodity of 1 unit of good X, he has to sacrifice some units of good Y. So let me see here how much he has sacrificed. Here he has sacrificed 5 units. Now what is the amount increase? It is 1. So 5 divided by 1 is 5. Now in order to consume one more extra unit of good X, he also has to sacrifice some more units of good Y. Now here see how much he has sacrificed good Y. He has sacrificed 4 units and amount increase was 1. Now look this very closely. If he wants to increase the consumption of good X, okay, he has to sacrifice some amount of good Y. Now as he is increasing, the marginal utility derived from each successive units of good X is diminishing. Now to become indifferent, he is now sacrificing less and less amount of good Y, because in the indifference curve all the points will give him the same amount of satisfaction. Now to have the same amount of satisfaction in a consumption bundle of good X and good Y, here in the good X he is experiencing a falling marginal utility. So to substitute that, to overcome that thing, he now sacrificing less and less amount of good Y. Here you see he has sacrificed, at the first place he has sacrificed 5 units. Now here he is sacrificing 4 units. In the next place he is sacrificing even less, it is 3, because he is having a falling mu marginal utility for commodity X. And in the last case also he is sacrificing even less. At first place he has sacrificed 5, then 4, then 3, then 2. Because why? Because he is having a negative impact on the marginal utility of good X. Negative impact, I want to mean that he is having a declining marginal utility for good X, for which he is sacrificing less and less amount of good Y. And this thing can also be explained with the help of a diagram also. Outline 2 axes. In the vertical axis we are measuring good Y. In the horizontal axis we are measuring good X. Now let's outline the points. For 1 it is 17, for 1 it is 17, for 2 it is 12, For 2 it is 12. For 3 it is 8. For 3 it is 8. For 4 it is 5. 4 it is 5. And for 5 it is 2. Okay. Now let's join these points. These were my points. Now say suppose I am at this one, this combination point. My drawing is not perfect because I am not using any scale and pencil, but you guys please use scale and pencil so that your diagram will be a very perfect one. Now say suppose he is at point, this was the second combination. So say suppose he is at point B, A, B, C, D and E. He is at point B. So at point B he is consuming 2 units of good X and 12 units of good Y. So he is consuming 2 units of good X and 12 units of good Y. Now if he wants to consume one more extra unit of good X, if he wants to be at point C with 8 units of good Y and 3 units of good X, he has to sacrifice some number of units of good Y. He now wants to consume 3 units of good X. As a result, he is now sacrificing 4 units of good Y. Here previously he was consuming 12 units of good Y, now he is consuming 8 units of good Y. But see, at the first place, when he was consuming at point A, to consume one more extra unit of good X, he has sacrificed 5 units. Now, when he consumed 2 units to 3 units, when he consumed one more extra, he faced a diminishing marginal utility of consumption of good X, because he is consuming one more extra unit of good X, and as a result the marginal utility gained from the one more additional unit of good X got diminished, and as a result, to remain indifferent, because we know from the very own definition of indifference curve that a consumer is indifferent in any of the points. So to remain indifferent now, he is sacrificing less amount of good Y. At first he sacrificed 5 units, now he is sacrificing even less, which is 4. And if he wants to consume at D point with 4 units of good X and 5 units of good Y, he is sacrificing even lesser units of good Y. He is sacrificing now 3 units of good Y. He is now sacrificing 3 units of good Y, and now he has came from 8 to 5. So this is it, my dear students. Full explanation of marginal rate of substitution. It is a bit tricky concept, I know, but if you face any query with this particular topic, feel free to comment below in the comment box, and I will reach out to you as soon as possible. Till then, stay safe, stay strong. Thank you.